Good morning, folks. We're going to start off here at spaceweatherlive.com. It is currently July 30th, 2022, approximately 11 a.m. Central Standard Time. I hope our creators keep you well and safe wherever you are in the world. If you happen to be new to the channel, please make sure to subscribe and hit that notification bell in case we have any critical future updates. And please also make sure to like this video and share it along other platforms so we can let people know what's going on out in our solar system, the effects it can have on our planet, and what's coming ahead. As we can see here, over the last couple days, our sun has been mostly quiet. We've been living in constant B flux, which is perfectly okay with me. We did have one spontaneous little C flare coming off the western limb the other day, and nothing coming at us from that whatsoever. However, as we come over here and we take a look at GOES 17, we're going to look at 304 angstroms of light over on spaceweatherpredictioncenter.noaa.gov. I want to show you guys something. We've got a lot of activity coming. Well, hopefully this thing will actually let me give it to me. There we go. We had a little eruption coming off of the western limb again. We can see the plasma coming off of that, which is pretty impressive. It's nice to see. But that's what a normal coronal mass ejection looks like. And more than likely it came off of a flare. It was pushed with a flare. But aside from that, when we take a look over here, as I mentioned in a previous video of mine, we're actually going to wind up having, towards the end of July, beginning of August, we're going to start ramping back up again. And as you can see, these plasma filaments, or strings, if you will, come arching off of here. I think that's exactly what we have in store. In fact, let's load this up and see. Now that we've got this thing loaded up, oh, I got to come down here and hit play again. Sorry about that. There, we can actually notice those filament rings on the left side, or strings, if you will. And I do like this one to be able to see these strings because we can actually see this coming around the limb. We're going to have a lot of activity. Okay, it's starting to ramp up, and as we've also noticed, our sunspot activity and our solar flux. In fact, we'll actually go to that here, and we'll take a look at that. We are way up. So we did have a nice quiet time. Looking over here at the 195 angstroms, we can see we have two coronal holes right here. We got a teeny tiny little small one that's wanting to develop, but we'll have to see where it is. But we're actually not riding on the equatorial plane because we do kind of oscillate up and down as we're going around the sun. We don't stay perfect. None of the planets do. We actually happen to be closer to the northern side of the equatorial plane at this current time, so these solar winds really should not affect us too much. We might get a slight bit of activity, but nothing too major for us to be worried about. Now, as we're looking here, this is actually our solar cycle for our radial flux, actually. Okay, and as we can see here, you can kind of barely see it here. This right here is how much radiation we've been taking on, and right here we actually peaked up at 130. Oh, come on, get there, you little stinker. There we go, 133.98. Now this was our current high, if you will, the peak high for this solar cycle 25. The total projection was only 135, but see how it's coming down, and we're not even here yet. Yeah, we're going to come up. See how this was spiked up, come down, spike up, come down, spikes up, come down, comes back down? Yeah, we're looking more like this, if not higher. And that's the truth. So as we're coming down, we're about to be spiking back up again. And if we look at here, this right here is our sunspot numbers. Okay, this is their original projection for sunspot numbers, 115. Okay, for the entire solar cycle 25. They were saying we were going to be solar cycle minimum. Nope, no, we're not. Not even close. In fact, it looks like we peaked out at 90, I want to say 96. Yeah, about 96. And they're projecting only 115, and we've already been really close to it. So, yeah, this ain't over yet. And this is showing what it could be, what their new prediction is from what has been happening. 246.7 possibly, and right here, the current one, before that, we were at 244 back around 2000, and we're supposed to be here. Well, that's at this point. That has not yet come to the center. So if you actually take the center and you ride it straight up, yeah, this thing still has to arch over to touch it. So we could be up 300-400. You know, according to this new model, from what they're seeing now, from the actual raise of it, the way that it's been raising up. If you actually follow the same curvature, we still have to get over to this point here where we're dead center of the solar cycle. So meet that thing up here. You know what I mean? I mean, we're going way up here. We're talking 400 or 500. Yippee-ki-yay. Now, as we come over and we look at seeds, we're looking at stereo ahead and this is stereo ahead, but this is with the reverse ink filter. We're going to take a look at something here, folks. And remember me telling you that just a minute ago, that at the end of July, beginning of August, we're going to start seeing a ramp up. Well, this right here is an eruption off the backside of the sun. Now, we are more over here, okay? So we're actually out of the blast zone, if you will, so that did not come at us. But does anybody see this right here? What is this round-looking object here? I don't know, but it's there for the entire duration, not just here, but you can see it here too. You can see it's right here. Now you can see the plasma also coming off on each side, which means it's pushing the plasma around this round object, whatever this round object might be, but it's being pushed off. Just something to keep in mind. Now if we actually go back one day, let's go back to one previous day. Let's go back to yesterday. We've actually got another one that does the same thing. And let's see here, where's that eruption? Right here. And now as we're getting, now this is off the western limb. As we're watching this eruption, you can see here something kind of all of a sudden get noticed. You see the plasma here, and then it kind of goes around right here. And there's a round object right here, and you can see that round object right here. Now let's zoom in on this. There we go. See that? We got some kind of a round object right there. Now, obviously, you can see the pixels here. You can see the big pixel, but you can see all the teeny little pixels in here. So it can actually give us that nice round look. So there's something there. Just don't know what it is, folks. Is that a planet? And look, you can still see it. It's still there. You can still see it here. So what is that? I don't know.
You tell me. Because no, I do not.
Taking a quick glance over here at our Italian model for our Schumann resonance. This right here has been over the past couple of days, and again, this right here is indicative of lightning. How it comes up like this, but then it comes back down. But now if you notice here, it's just a straight up brick wall. Boom! This is CERN turning on. And then see how it all of a sudden just kind of slams down as well? This is a CERN reaction from them turning on. Same thing here, how it comes here like, oh, it could be lightning, and then they kicked it on. That is from CERN. Same thing with this one. That is CERN. 100%. This one, this is actually from lightning coming up and down. Now we also know that CERN creates lightning. That there are all kind of electromagnetic anomalies all around CERN. So who's to say that all of these aren't from CERN kicking on? That the lightning was created because of CERN? Not sure. But it's something to keep in mind. Now, one of the other things, we come down here, we can see our color chart variation of the different frequencies. Each color is a different frequency, and it also correlates with the chakras of the human body. And we can see that there is some activation cleansing, however you want to see. But yeah, being over in Italy right about now, you definitely have something going on. I mean, all kinds of multiple colors. Looks gorgeous. I mean, look at this. What in the world was happening here? Woo! It's very, very interesting. And right here, right here is Cumiana, Italy. Okay, this is where the base is that has the Italian model for the Schumann. And right here, this is where CERN is. Do you see how this model is the tattletale for CERN? I'm sure you do. For those of you who might have missed it, I posted in my community group last night. I was live with Rise Above Live, number 74. 7 and 4 is 11. Giannis, dope! I was a guest speaker and spoke about a lot of different things that I have on satellite, spoke about solar weather, spoke about a little bit deeper things. We also happened to mention about the Earth and with it being a globe. I know some people don't really agree with the Earth being a globe. They feel it's flat or a crater. But in my experience, and from following the science and from my own personal experience, I look at it as a globe. And one of the things, and some people are, oh, globe earthers, whatever. Well, let me explain something to you. There's two things that we have to keep in mind. And big shout out and big thanks to Rise Above, to Lance, Master Lee, Inner Guardians, Sheep Farm. Big shout out, big up. And Rob, Esoteric Knights of Malta. I follow all of these guys. And I recommend everybody do the same. For those of you who are subs of mine, they're really good guys, like-minded individuals. And I can't wait to meet them one day when I actually jump over into England. I'd love to do an in-studio with everybody, meet everybody. It would be great. But we were talking about, to get back to the Earth thing, here's one of the things that is kind of difficult to explain when you're talking about a flat Earth or a crater Earth. And I've never heard any kind of a good scientific explanation for it. One of those being the equatorial bulge. Okay, it's about 43 kilometers wider at the at the equator than it is from pole to pole. Okay, so from the North Pole to the South Pole, you've got one measurement, but along the equatorial plane, you've got 43 kilometers wider. Well, that's because of bulge. The water, if you were to actually measure the water, the sea level from England, which is where sea level for the whole world, believe it or not, they consider that to be sea level in England, and then you come down here to along the equator, you're looking at 21 kilometers more water, or depth of water, higher water along the equator, anywhere on the equator. You can go anywhere on the equator, and it is 21 kilometers deeper than it is in England. So if the Earth is flat, how do you get that? If it's a crater, how do you get that? I don't understand that. That does not make a lot of sense to me. The other one, and now, I mean, the reason for that is if you know anything about energy, and especially about centrifugal force, grab a little kid by the hands, spin around in the circle, what's going to happen? Their feet are going to come off the ground, right? I mean, all kids love that, right? Same kind of thing. You're spinning around, and it does the same thing. Hold yourself a cup of water and spin around in a circle, and you're going to see it wanting to escape the cup. It's the same kind of force. Okay, the other thing here is something called the Coriolis effect. Okay, the Coriolis effect affects many things on Earth. It affects the way that the ocean currents travel. For those of you who are boaters, you should know about the ocean currents. You got your Pacific currents, your Australian currents, your Atlantic currents that not just go from the equator to the North Pole, but also go from the equator to the South Pole. And that's how the currents actually stay in their circulation. How they do, they get warmer and then they come back down, then they cool off. And that's, I mean, animals, whales, dolphins, fish, they all use those currents for their migrations, and that's all because of the Coriolis effect. Now, the other thing that Coriolis effect does, and absolutely doesn't, if you know any pilots, any kind of a major airline pilot, and you talk to them, okay, right here, Coriolis affects wind that we have here on Earth. It also affects aircrafts. So any pilot will tell you that you have to calculate the rotation of the Earth from where you're taking off at to where you're landing. I mean, has anybody ever been on a plane and you land 10-15 minutes early? Well, they didn't do an exact calculation. Okay, and so you arrived early. Not only does it affect your distance, but it also affects on your projection. So if you don't make your measurements correctly, you could wind up being 50 miles to the east or 50 miles to the west, and because the Earth is rotating under you while you're traveling. Okay, that's another thing, and you can't on flat Earth or on a crater Earth, you can't really explain that one. The other thing is ballistics. I myself am an avid shooter, and I've shot over 1,200 yards. Well, actually 1,110 yards, about 1,200 yards, and hit a 10-inch plate 10 times in a row. Now, I did go to schooling for that in Cody, Wyoming, where they actually teach you long-range shooting, how to shoot long-range. And I absolutely enjoyed it. And you have to, once you get out past certain yards or meters, you have to take into account the Coriolis effect, which is the rotation of the Earth. Because when you shoot a bullet, the Earth is still rotating as that bullet is suspended in the air as it's traveling through the air, not suspended, but as it's traveling, it's going in one direction. So if you don't take into account the rotation of the Earth, you could try shooting at something dead on, and you're going to miss. You're going to be to the left or to the right of your target. But if you calculate your rotation, you can hit your target. Does that make sense? So remember to keep your eyes open, no fear, and remember that love is the only way forward. So